This question is on radioactivity and it involves background radiation. So you have a detector over here and in front you have a radioactive material that's giving out the radiation. The detector has a reading of 536 count per second. You have to understand that this count rate here is contributed by two sources, mainly from the radioactive material that you're measuring plus the background radiation, which is given 44 counts per second. Next, you are given that the half-life of this radioactive material is 34 hours and you are asked what's the reading on the detector after 68 hours. So the first step that we need to do is to find in the duration of 68 hours how many half-lives have passed. So the first step is number of half-life. We'll just basically take 68 divided by 34 and you have 2 half-life. Then next, since I mentioned that the radioactive source, the 536, includes the background radiation, so the first step you need to do is to minus the background radiation of 44 counts per second and you're left with 492 counts per second. So this 492 is purely from the radioactive material. So after one half-life, which is 34 hours later, the amount the counts per second will be reduced by half. So you divide by 2, that will be 246 count per second. And then after another half-life, because there are 2 half-lives here, so you divide by 2 again, it becomes 1, 2, 3 counts per second. Now that's where a lot of students make this careless mistake. They get 1, 2, 3 here, and then B, there's 1, 2, 3 counts per second, and naturally they will just treat it as the answer. But don't forget, the detector is always, the reading of the detector actually detects both the radioactive source and the background radiation. This 1, 2, 3 counts per second is basically from the radioactive material alone. So you need to add back the background radiation plus 44. That's why you have your 167 counts per second on the detector. So the answer should be D. Since we're on the topic of background radiation, I can also present all the information here on the count rate against time graph. So this is a typical shape of a count rate against time graph as the radioactive material is decaying. But take note that for this graph, the reading are straight away from the detector, which consists of background radiation also. So that means to say this will be your 5, 3, 6, and let's say you want to find half-life from this graph. So what you do is, same thing, 5, 3, 6, you need to minus away, and it's given to you that the background radiation is 44 counts per second. It will be 492. So you really have to look for, I'll use blue here, this is 492 is actually the count per second from the radioactive material. So you should start from here, 492. After one half-life, which it will be half the count rate, it will be 246. So you should look for half the value, 246 here. And then that is not, over here, that is not the half-life, okay? Because the reading, the red color curve here includes the background radiation. So what you need to do is plus, if this 246 plus 44, all right, then that will be 290. So 290 here, okay, I use back the red color here. So 290, then you come over here, and by right, this will be 34, and that is the half-life of this radioactive material. So if you want to continue to put in 2 half-life later, how about 68? How is it represented on the graph? You can, after 246, you should not be looking at 290. So from 246, that's without the background radiation, purely from the radioactive source. After another half-life, you half the value, there will be 1, 2, 3 here. And 1, 2, 3 over here, this is purely from the radioactive source. But from this graph, the curve involves the background radiation. So you have to plus back 44 and that will give you 167. So you have to plus back your 44. So the final value should be your 167. Okay, so you look at the graph here, that this point here will be 68. Of course my graph is not really proportional, but I hope you get the idea. And so if there are questions involving background radiation, I hope you can be mindful and get the correct answer. All right, thank you.